So welcome back to this new sequence. And during this sequence, we will implement a story generator. You already have seen that types play a central part in OCaml programming. And there is a very common motto in OCaml programmer saying that when you have written the right type declarations, then you are not too far for writing the right program. And that's why we will follow that kind of programming method called type-directed programming method to implement our story generator. So let us now look at an implementation of a story generator. What I want to illustrate in this demo is that you can first write very specific type declaration in OCaml to specify your problem, the structure of what you are trying to compute. And after that, you just have to follow the structure of these types to find what kind of function must be implemented. I won't give all the details of this implementation, but you can find it online. So let us start with the type declaration. To implement a story generator, we have to understand what a story is. So we can say that a story is an initial context where the story begins. In this context, there is a perturbation event, something that happens. And these things generate an adventure, a list of events, that will get us to the conclusion of the story, which is usually a context in which the characters are happy. So a context is formed by a list of characters. And a character will be characterized by a name, a state, and a location. Now we again have to refine this definition by saying that an event may be external, it can be done by the environment on the character, something happens, or it can also be an action of the character to the context. So now we have the general structure of a story, and we can try to find nice examples of what, for instance, can be the state of a character. A character can be happy or hungry, in our case. And in our story, a character can do two things, can eat or go to the restaurant. It can also be located in two different places, an apartment or the restaurant. And we have finished with the type declarations, and in fact, that's the really important information for our development. To understand that, I will show you several functions that are directed by the shape of this type declaration. The first one is the function named makeStory. So here it is. makeStory here takes an initial context, choose randomly a perturbation, something that happens in the initial context, and after that, makeStory tries to end the story by finding a sequence of events that lead to a context which is happy. In the end, the story is the context, the initial context, the perturbation, the adventure, and the conclusion, which has been built by the previous two functions. Now, how do you end a story? It's a recursive function that recurs as long as the context is not happy. So when it is happy, you have finished, and you can return the list of events that you have accumulated along the recursion. Otherwise, you have to find something that can happen, an event. And this event leads to a new context, which is on which we do a recursive call. So what does that mean? To be an happy context. Well, we have the characters of our context, and we will say that if all the characters are happy, then we are in a happy context. So as you can see, and you can continue to analyze this program like that, the functions are pretty simple because all the intelligence to solve this problem was in the type declaration. The only thing that you do when you implement the functions is to follow the structure of the types that you have defined. So at the end, once you have been able to generate a story, you can tell it. So again, by following the structure of the types, you can write functions from the type story to string. This is, for instance, how you tell a story. You start with once upon a time, then you tell what is the initial context. You say that one day something wrong happened, and you describe this event. After that, you tell the adventure of the story, and you conclude by saying that at the end, the piece is restored. And you describe the final context. So, for instance, here is a story that is starting with Sophie at the apartment being happy, and Socrates at the apartment too being happy. So we've just have seen that types are very convenient to direct the programmer into what must be implemented and when. But for the moment, we must admit that our stories are a bit boring. We want to adjust some type declarations in order to improve the quality of these stories. What we will see is the fact that the type checker is able to assist us by pinpointing what part of the code must be updated. So now we will assume that our characters are zombies and that the restaurants can be closed. So now, if we want to generate more interesting stories, we may want to assume that our characters are zombies, and so they are able to do an extra action, which is eating a human. So we have to change the types that describes the possible actions for our characters, and this change, of course, has an impact on the functions that must be written. The idea is that if I ask the type checker to now verify my program, it will pinpoint what functions should be updated. Here, for instance, I can read that a function is now not exhaustive because I must deal with the case where the action is eating a human. So another remark is how concise you can write your program. In the first version of our storyteller, we had to write 178 lines of code. In fact, a skilled OCaml programmer would have written the same code in less lines. And his secret is to replace that kind of functions using a one-liner like this. And the basic ingredient of this secret is to use higher order function. Fortunately for you, this is the next week topics.